Good morning, dear students. Our today's topic once again for class 9th physics, and the topic I have chosen is upthrust in fluids, Archimedes principle and flotation, chapter 5. And before this we have discussed about the pressure in fluids and atmospheric pressure. Okay, we have discussed what will be the pressure if the height is h and the density of the liquid is rho. So pressure we have derived h rho g, and before this we have done what is upthrust, what is simply pressure is equal to upthrust upon area. These formulas we have discussed and we have solved some numericals on the basis of these formulas also. Okay, now the proceeding chapter will be of chapter 4, upthrust in fluids, because we have done with the pressure in fluids, atmospheric pressure. Then after the chapter comes upthrust in fluids. What is upthrust in fluids actually? Listen carefully. I have made one figure also and I have written the definition. Buoyant or upthrust force. Before I explain the definition of this upthrust or buoyancy, some basic experiments we have done, not purposely but accidentally we have done, and we have felt what is buoyancy. We all have done or we all have experienced one buoyant force inside the water whenever we put any water jug or any glass inside the water. As soon as we go with the jug, the water jug inside the water, we feel some pressure. If the jug is empty or if the glass is empty and we are keeping the glass or the jug inside the water, then we feel that something is there which is moving or which is giving the upthrust force or upright force to the jug. Because of that, the jug is not going down. We need to give some pressure, we need to give some power to the jug. Then only the jug goes inside the water. And that force which is acting upon that time on the jug or on the glass or any object is called upthrust force. It is very easy. Whenever we have any cardboard or we have any thermocol piece, you have observed that thermocol piece doesn't go inside the water. What is the reason behind? Which power is acting on that? So that power is called buoyant force, or you can say upthrust force. Okay, thrust we have done. Thrust is what? The pressure exerted on the surface because of the weight of the body. But now it is upthrust force. Upthrust force means upside, opposite to the direction of the gravitational force, you can say. Because of water or because of liquid or because of any liquid whose density is more or less, on the basis of that the upthrust force will be more or less. So let us see what the example is and let us try to understand with the help of the figure what the upthrust is and why the objects are floating on the water. Okay, the main reason why the objects are floating on the water is upthrust force, or we can say the buoyant force. Let us see the definition for buoyancy and the same for the upthrust force. Upthrust and buoyancy actually are same words. Okay, now the upward force exerted on a body by the fluid. Fluid means any fluid can be there. It may be water, it may be sea water, it may be oil, it may be any other liquid. Okay, in which it is submerged, जिसमें कि डुबाया गया है. ठीक है, submerge means डुबाना, is called the upthrust or buoyant force. Let us see once again. The upward force exerted on a body by the fluid in which it is submerged is called the upthrust or buoyant force. If simply we have water in any container and if any object is there upside, any block of wood or any thermocol or any other thing which is very light, you have seen that the object is here upside the water, it is floating. Why it is floating? Why it is not going down? Whenever we are putting any brick or any stone etc., any piece of iron, then it is going down. But in case of cardboard, in case of wood, in case of thermocol, why it is floating upside? Let us see. One power or one force is upside there which is pushing upside the object. This force is called upthrust force. No doubt there is the weight no doubt there is the weight of the object which want to go down because of the W, but that W is very less than upthrust force F, okay, or buoyant force FB we will write, okay. So because weight is very less and the buoyant force is very much, the difference between the FB, that is buoyant force, and the weight is very much. That's why the object is floating on the surface of the water or on the liquid or on the surface of the fluid. Now let us see what happens. I have made one figure and there are some conditions. You have observed that why any object is floating on the surface of the water, why any object is floating but not on the surface, just below the surface of the water, and in some cases you have seen the object is not floating, it simply goes down. What is the reason behind? Let us see. I have made this figure. This is the object, any block of wood or anything which is floating on the surface of the water, but not upside, just on the surface, going down, okay. So the W, that is weight of the object, will act downward direction. W is equal to m into g, mass into acceleration, will always act downward direction. But the force because of water, that is upthrust force we called, it is acting upward on this object, and that is, let it be F dash B, upthrust force, maximum upthrust force, okay, F dash B. And there are few conditions why the object is floating on the surface. So there will be three figures. Let us see. One figure we can draw like that. The same object is not there, maybe some difference in the weight, so the object will float like that. No doubt the weight of the object, W is equal to m into g, will act downward direction, but upthrust force F dash B we will call here is acting upward. The liquid is same, or you can say the liquid is different, then the density will be different, so the same condition can come for the same object, okay. And one more condition will be there, in which if any object is kept but it goes down on the surface of the liquid or on the vessel, wherever we have kept the object. So there also the weight W will work. W is equal to m into g. Here also upthrust force FB will act upward direction, but the object will go down. Why? See, I have written condition for a body to float or sink in a fluid. What are the conditions? Listen carefully. In this first condition, F dash B, that is upthrust force, F dash B is upthrust force, okay. W will be the weight of the object which will act in the downward direction, okay. So W we have and FB we have, W we have and FB we have, okay. So the first condition is, if F dash B is greater than W, if upthrust force is greater than W, then there will be a huge difference between F dash B and W, and that resultant force will be the reason why the object will float. If F dash B is greater than W, there will be such condition, F dash B is greater than W. The object will float on the surface of the water or on the surface of the liquid, whatever we have. Now let us see the second condition we have, or in both of these conditions the object will float on the surface, but the surface, on the surface and just below the surface are two different conditions. Now if F dash B is just equal to W, that means if the weight of the object and upthrust force working on the surface of the object are same or equal, there is no difference, or you can say if F dash B minus W is 0, in such cases the object will flow like that. The first condition, if FB, that is upthrust force, or upthrust force means buoyancy, is more than W, then it will flow like that, float like that. Second case, if F dash B is equal to W, it will flow like that. And the third condition, or you can say the second condition mainly, this is the first condition. Second condition is if F dash B, that is upthrust force, is less than W. This is the main point. if upthrust force is upthrust force is less than W, that means weight is more. The upthrust force working W is more than F dash B. There are some conditions, or you can say if F dash B minus W is coming in negative, in that kind of cases, the object will sink. Okay, in case of bricks or stones, in case of iron, wherever the buoyancy is not more than the weight of the object will sink in the water or in the fluid. But there are some cases. I need to explain you what is Archimedes principle. In what kind of cases, when the volume is more and the displaced weight, the displaced volume of water is more, and the weight of that is more than the weight of the object, in such kind of cases the object will flow. But that is a different matter. For the first condition we have this much: upthrust. What is upthrust? What is buoyancy? For that we have three conditions. Please note it down. We'll meet very soon once again with the second lecture of this chapter. Till then, thank you so much. See you soon.